Alright, today we'll be doing optimization example. Right, let us look at the question. A rectangular enclosure is to be fenced in on three sides. Right, so with the fourth side being formed by a river, the cost of fencing at right angles to the river is 200 rand per meter, while that parallel to the river is 100 rand per meter. Right, so if the enclosure area is to be 100 meters squared, find the dimension so that the cost of fencing is a minimum, and verify your answer is a minimum by performing the second derivative test. In this situation, we have this guy is meter squared, so that is going to be our area in meter squared. Right, so we are going to pay close attention to detail here. They say there is a river there, and with the fourth side being formed by a river, so here we are going to draw a rectangular enclosure. So this rectangular enclosure is going to be like that. Right, so this being a river, as they say. So in optimization, we must pay close attention to detail. Right, so the cost of fencing is 200 rand at a situation whereby we are at right angle to the river, which means perpendicular to the river, which is from here to there. It's gonna be 200 rand, 200 rand per meter. Right, and then this is the same thing, because it's at a right angle, it's the same as that, is 200 rand per meter. And while the parallel to the river is 100 rand, is 100 rand per meter. Right, so let us note this one as y, the one that is vertical, the one that is perpendicular to the river, and this one is gonna be y, so this is gonna be the x, this one. So looking at that, we see a rectangular, a one-dimensional rectangular. So in a one-dimensional rectangular, when we calculate the area, we are not going to include the height, because this is a one dimension. So the height is not going to be included. But the formula is like this, of a rectangular, of a 3D dimension rectangular. But then here, because it's a 1D dimension, height is going to be equivalent to 1. Right, so this one is going to be 1. Here we'll be left with length multiplied by breadth. Right, so we have the area. They gave us the area here. If the enclosed area is to be 100 meters squared, so we're gonna have our area there is 100 is equal to, the length is the longest, the breadth is the shortest side. Right, so what is our length here? Is this one here. It's gonna be x. And remember, don't use this length, don't use this, the cost, as your length. This is not the length, this is the cost. The cost is 100 rand for this side per meter. Right, but then the length is x, so we're gonna come and write x there, and then the breadth is gonna be y multiplied by y. Right, so we make y the subject of the formula. We're gonna divide by x there, we divide by x there, so x will cancel x, so this is going to disappear. We'll be left with y there. This can be your equation number 1. Equation number 2 is to talk about the cost. All right, so what is the cost there? The cost is equal to what? Is equal to the first cost. Remember, the first cost, which is from here, let me change the pen. The first cost, which is from here to there, is 200 meters, 200 y. Right, so the second cost, which is from there to there, right, is gonna be you're gonna add plus it's 100, right? So it's gonna be 100x, and the last one, which is from here to there, is gonna be 200. It's gonna be 200y, right? So when you are there, this and this, you are going to group them, and then you add them together. They are going to give you 400y plus 100x, right? So we're gonna have our cost there. This can be your equation number 2, right? So let us proceed forth. So now what you must do, remember, they are asking you to find the dimension so that the cost of fencing is a minimum, right? So what you are going to do next is to substitute the y into the equation number 1 into equation number 2. So you can write here, sorry, sub equation 1 into equation 2, right? So equation 2 says cost is equal to 400y. Okay, our y is gonna be 100 over x, and then we're gonna have plus this one plus 100x. Right, so when we are there, this is going to give us, when you multiply 400 by 100, it's gonna give you how much? It's gonna give you 40,000. So you're gonna write your 40,000 there, all over x, so that is this, plus your 100x, right? And remember, I want you to remember this, when we say 2 over x, this is the same as 2 multiplied by 1 over x, right? We do this kind of a thing when we want to derivate. So this is derivatable. It is derivatable, this one, because our this is simply going to give us 1 over, it's going to give us 2 multiplied by x to the power negative 1. So now we can derivate. So when something is in this situation, we do that so that we can derivate, right? So this one is going to give us 40,000, 2, 3. Now remember, this is c. Now this one is going to be c in terms, this is c in terms of what? X. In terms of x, right? 40,000 x to the power what? Negative 1 plus 100x. So we derivate this. Negative 1 multiplied by 40 is gonna give us, okay, let's write x in terms of x, derivative there. So we do negative 1 multiplied by 40,000 is gonna give us negative 40,000, right? 2, 3, and then when we subtract negative 1 by 1, it's gonna give us negative 2. So this is gonna be negative 2 plus, when we derivate this, we're gonna get 100. We get 100, right? So when we are there, this, we are going to equate this to 0. We equate this to 0 so that we can find the value of x, right? So when we equate that to 0, and then we have this one here, which is remember, something like this is the same as that. Remember, 1 over, it means, it simply means x to the power negative 1, right? It simply means x to the power negative 1. So when we are there in this situation, this means that, right? But when we are in a situation whereby we say this, it will mean now this is going to be to the power negative what? 2, right? If we're gonna have 5 here, it's gonna be to the power negative 5, right? I hope you understand that. So it's gonna be 40. Okay, let me write this like this. Is 40,000 over x squared plus 100. Right. So when you are in this situation, you know what to do. You know what to do. I hope you understood here. You know what to do. You take this one to the other side. Maybe you can just add this. You add this side and also add it that side. But then a different explanation, the same thing, is to take this to the other side. That is as simple as that. So you take this to the other side, it's going to change the sign. If it was negative, it's going to be positive this side. If it was positive this side, it's going to be negative. So we're going to have 40,000 all over x squared is equal to 100. Right. So we're gonna cross multiply here. This 100 is the same as 100 divided by 1, because 100 divided by 1 is going to give us 100. So this is the same as that. So we're going to cross multiply 1 multiplied by 40,000, 100 multiplied by x squared. We're going to have x squared is equal to 40,000 all over 100. And then we apply a square root after getting this. Right, this is going to give us, how much is going to give us? 400. So when this gives us 400, it's going to be x, when you apply a square root, like that, square root of 400. Square root of 400 is going to give you positive or negative value. So the value of x here is going to be positive or negative 20. Right, so when you are there, the value of x cannot be negative, since we are talking about the length. X is our length there. It cannot be negative. So x, therefore, x is equal to 20. Right. So now we use a second derivative to test if our answer is a minimum. Come in. We use a second derivative to prove that our answer is a minimum. So gonna be C, second derivative in terms of x. So when we apply a second derivative on this, so we're gonna, it was this. Remember when I applied a first derivative, we got this. So we're gonna apply a second derivative on this. We're gonna apply another derivative on that. So it's gonna give us positive. So this is going to be 80,000. Right, that is gonna be 80,000. It's gonna be 80,000 x power negative 3. Right, so when we derive a constant, it's gonna give us 0. Right, so in this second derivative, we substitute our value of x to see if this value of x is indeed a minimum. Right, to see if the value of x is indeed a minimum, we substitute that value of x that we have found. So here we're gonna write 20 to the power negative 3. Right, so this, remember the answer that we are going to get there. I want to write something here for you. The answer that we must get, remember, if we apply a second derivative and we substitute the value of x, we get a number that is greater than 0. It means our answer is a minimum. But if we get the one that is less than 0, it means our answer is a maximum. That simply means when we are in a range, if we get an answer that is greater than 0, it means we begin from that answer, which is 20 up until positive infinity. Right, so you can see that here when you substitute 20, you get an answer that is greater than 0. It means 20 is a minimum. It is bound here. Any number less than 20 is not included. 20 up until infinity. Right? But if we get a value that is less than, if we derive twice, we get a value that is less than 0. It means we begin at negative infinity up until that value, and here our value is 20, right? 20, you can see that it is bound there. We are coming from negative infinity until 20. It means 20 is our maximum. So note here, when you derive twice, you get a value that is less than 0. It means this value of x is a maximum. When you derive twice, you substitute the value of x, you get a value that is greater than 0, which is this situation. It means that value is a minimum. Okay, I hope you understood that. So you're gonna derive twice, and then you substitute your value there, and then you see that your value is greater than 20. Is greater, is it not? Is greater than 0. Then the minimum cost is at x is equal to 20. Therefore, okay, therefore the minimum cost, therefore the minimum cost is at, therefore the minimum cost is at x is equal to 20 and y is equal to 5. Also go and find the value of y. The procedure doesn't matter, you only get 1 mark for finding the answer, the final answer of the y. So go and substitute, and you can substitute on this formula here. Our first equation, substitute x, since it's the one that you found first, you substitute x, you get y. So the minimum cost is at 20, and that value of x, that value of y, when you substitute this x, which is 5. Right. So this will be the end of this example.